Nice and cold up top. All right. Wow. All the way down to 15 degrees. And that is a nice, thick, creamy product. It's not over frozen. It's not going to just flop over. It's holding a nice thick peak there. We're going to let this recharge because this is a customer repair. All right, and the machine is finished recharging on the left side. Let's go ahead and pull one on the right. That beautiful cone. Wow. Almost down to 14 degrees. Yeah, nice thick creamy product there. And then we'll flop off, holding a nice thick peak. Alright, we're gonna let that recharge so you can see exactly how long that time takes to recover, that side takes to recover. It also looks like you may have a small leak of mix from your left side. We're going to go ahead and replace your rear cylinder gasket on their left side, just to make sure that that's not a contributing factor. Alright, looks like our machine is finished charging. So let's go ahead and pull a nice fat cone off the middle. Nice solid 16 degrees. Nice and creamy all the way through. Holding the stiff peak. pull one more. It's going to let this recharge, and then we're going to talk about what we found in the system and explain exactly why it failed and what's going on and what we can do in the future to prevent it, if anything. Alright, the machine is finished on one side. And now it's completely finished. Alright. So let's pull one more and then let's start. I saw it's 16 degrees. I mean, that is just perfect, creamy consistency, just stiff peak. I would buy that happily. Okay, now that we've got the machine running again, let's talk about exactly what happened and why it failed. This component here is known as a contactor. You've got 3 in your machine. Each motor has a contactor and your compressor has a contactor. They live down here behind this main panel on the bottom. There's 4 screws, 2 in the front and 1 on each side. Move the strap out of the way, you can kind of see that screw right there on that side. And then 1 on the other side. I'm going to take those 4 screws out. And then behind that, there's another panel. You can kind of see that right there, that stainless, that steel panel, that gray panel. That's going to have 4 screws. They're going to be 5/16 head size, hex head. And there's going to be 2 about here and about 2 about here. And then that panel will come towards you. Behind there, you'll be able to see 3 contactors. 2 of them will have a reset attached to the bottom. So your compressor contactor for this unit will look pretty much like this. It'll have some wires going in the top, some wires coming in the bottom, and that'll be it. The other ones will have a little module here screwed into the bottom that'll have a cutout where you can press on it to reset your motor, and that's how you'll know the difference between them. Now on this particular model of contactor, you've got an easy way to tell if it's engaged. This is in the off position. Right now there's no contact between these points. And they go like across like that. So what it's doing when it's on is it's connecting this point and this point and allowing it to flow through. So originally when I spoke to you on the phone, I believe that your compressor was running based on the sounds that you were describing. However, it wasn't running. This contactor had failed, and this was not allowing energy or electricity to pass through to your compressor to turn it on and for your system to cool. We leak tested your system. We let it sit for over 24 hours with a 150 psi in the system for designated leak testing. Came back, it held perfectly. So there's no leak anywhere in the system all the way through. We engaged all the solenoids. We made sure that every point in the system was at 150 psi and it held perfectly. So there's no leak in the system at all. It was simply this contactor had failed. And the way that it failed is inside of here on coil, on position contact A1 and A2, you have a coil of wire inside that acts as an electromagnet. It can burn out over time. It's just a coil of wire that's got a lacquer coating on it or some sort of enamel coating. And over time they can heat up, break down. I mean, it's just a very thin piece of wire, so it's normal for them to fail. You can see on the bottom here we've got a little burn spot. And when I checked the resistance across A1 and A2 with one of the wires removed to make it a solitary circuit, it had no continuity across it. So your contactor coil was totally burned out. The signal was getting to it, but it was just broken inside. So there was nothing for it to engage, no electromagnet, no click over, no nothing. So on this model, here is the on-off, or the off-on position. Excuse me, there's a little bit of noise in the background. I'm a little distracted. So right now we're off in the O position, the 0. But when the contactor's engaged and on, it'll be clicked over here to the left on the 1. I don't know if you can see that too well. On, off, on, off. So, if you ever want to know if my motor is engaging, my compressor is engaging, something like that, you want to just do a quick look inside of the machine and say, okay, is it a minor electrical something, or is it something bigger? You can take a look in and you can see, okay, is my contactor engaged? If you have the left side on wash, you hit the reset, the motor doesn't turn, you're just like, well, what's going on? You look down in there and it's in the off state. Well, it could be your coil burned out, or it could be that the circuit board down there, that green board, is not getting the signal, or it's not passing the signal through. So it could be just a simple electrical issue as opposed to my very expensive motor failed. So it may give you a little peace of mind just being able to look in there and know, okay, this is exactly what's going on, and I know that it's engaging or not engaging, and you can go from there, and you can, maybe save yourself a little bit of time and take some of the sting out of not knowing. I think the biggest problem and the really the biggest fear about any machine glitch or error or breakdown is that it's going to be $1,000, $2,000, $5,000 to fix it. And I understand that panic. I own a motor vehicle myself. I understand completely what it's like to think, oh man, I'm gonna have to spend all this money, and then you take it to a shop and you find out it's like a $50 sensor or something like that, but not knowing. So if anything that I can teach you here today can take the sting out of not knowing and offer you a little reassurance when your machine breaks down, that's what I'm here to do. So we've gone through everything. We checked out all the solenoids. We checked out all the contactors. We went through it very thoroughly. I'm very confident that your machine will run perfectly fine. If a contactor does fail, you can always look down in there and see, okay, it's just not engaging. It just burned out. These aren't, terribly expensive, depends on really where you are and what the cost of things are anymore. I used to pay $30, $40 for them. Depends on the model and just a lot of other factors, amperage, all that, but not terribly expensive. But just, I hope the explanation brings some peace of mind, and maybe you can benefit from that information in the future. I'm sorry to get a little long-winded here. I'm very sorry that this happened either way, but we're always here to take care of you when situations arise. So, just reach out to us if you ever have a problem. We'll take care of you. All right. Thank you for watching. Have a nice day.